Everyone, good evening. So here we shall solve from the question number 31 onwards. So here it is told AB is a line segment and L is its perpendicular bisector. So AB is a line segment. The line L is its perpendicular bisector. This is suppose the line L. That is the perpendicular bisector. Suppose it intersects AB at the point C. So then it means that it is told that L is perpendicular to AB also and C should be the midpoint of AB also. So if a point P lies on L, let's say point P lies on L, show that P is equidistant from AL. So it means I have to show that PA is equal to PB. So it is given that L is perpendicular to AB and L intersects AB at point C such that AC equal to BC. Means C should be the midpoint of AB. So it means L is the perpendicular bisector of AB. And P is a point on L. P is a point on the line L. So we have to prove that P is equidistant from the point A and B. Which means that is, I can say, that is PA should be equal to P. That I have to show. So here the proof is that I will tell that in triangle PAC, in triangle PBC, angle PCA that is equal to angle PCD, which is equal to 90 degree, This is why it is given that L is perpendicular to AB. So I can say PC is also, so from here also I can say PC is perpendicular to AB. Should be, so we can write it in the given only. Since L is perpendicular to AB and P and C are points on L. And here you can see PC is the common side. Or I can say PC equal to PC also. And also we can see that AC equal to BC, which is also given. So hence, therefore I can say that triangle PAC, that is congruent to triangle PBC by SAS, by side angle side. Since we have, so this is given AC equal to CB and this is the common side. So we have shown that these two sides are equal and the included angle is also equal. So by SAS rule of congruency, these two triangles are congruent. So I can say that PA equal to PB, P equal to PB by CP CT. So hence prove that the point P is equidistant from the point C. Then here it is told if the altitude of one vertex of a triangle bisects the opposite side. Altitude of one vertex of a triangle bisects the opposite side proves that the triangle is isosceles. That means I have to show that suppose if I tell this triangle, suppose PQR and PN, suppose PN is the altitude from the vertex P on the side QR, and suppose it bisects the opposite side. So it is given that PN equal to means QN equal to RN. Then we have to show that triangle PQR is isosceles. So it is given that PN is perpendicular to QR, or I can say that PN is the altitude on the side QR in triangle PQR, such that PN bisects the side QR. That is, I can say Q1 equal to Rn. Q1 is equal to Rn, and then we have to show So it bisects the opposite side, and you have to show that this triangle is isosceles. So we have to prove that triangle PQR is isosceles. So the proof will be like this. So I will write that in triangle PQN and triangle PRN, PN equal to PN, or I can say PN is the common side. PN is the common side, and QN equals to RN. QN equals to RN. QN is equal to RN. Which is given only. And angle P and Q, that is equal to angle R and P and R. Angle P and Q is equal to angle P and R, which is equal to 90 degree. Since it is given that PN is perpendicular to QR. So here we have used two sides are equal, and the included angle is also equal. So I can say triangle PQN, that is congruent to triangle PRN by SAS rule of congruency. The SAS rule of congruency. SAS rule of congruency. And therefore I can say that PQ is equal to PR by CT. Therefore I can say that PQ is equal to PR since it is CT. So therefore triangle PQR is an isosceles triangle. So hence proof. Then in question number 33, it is told if the bisector of the vertical angle of a triangle bisects the base, prove that the triangle is isosceles. This is the triangle, suppose ABC. The bisector of the vertical angle. So the bisectors of these two angles are equal, and it intersects this side at point D. It bisects the base to prove that the triangle is isosceles. So it is given, suppose that in triangle ABC, AD is the bisector, or I can say in triangle ABC, the bisector of angle A, bisects the base BC at point D. So I can say that, so it is given that BD is equal to CD and angle BAD, that is equal to angle CAD. So this is given. These two angles are equal. BAD is equal to CAD. So we have to prove that So we have to prove that triangle ABC is isosceles. So the proof is like this. Uh, the bisector of this angle bisects the base. These two angles are equal. These two sides are equal, and this is the common side. Now we can extend this. We can extend AD to the point E such that AD equal to DE. Then we can join this PE and CE. Then we can see that the diagonals bisect each other. So it is a rhombus. So all the both sides are equal. We can also say this by doing this that uh, so the diagonals bisect each other. I said so the diagonals bisect each other. It means it is a parallelogram. It is a parallelogram. So hence this angle will be equal to this angle. This is x, then this is also x. And if this is x, then why these two angles are same, it is told. This angle is also x. So opposite angles are equal. So now it is a parallelogram. So it means that opposite sides are equal. This side is equal to this side, and this side is also equal to this side. And since these two sides are equal, since why these two angles are equal, so these two sides are also equal. So these two sides are also equal. Okay, so here we need one construction. We need one construction here. We'll tell that AD is extended. It is extended to the point E such that AD is equal to AD is equal to D. AD is equal to D. And then B, the lines BE and CE are drawn. So then we will write the proof. Proof is that. So here you can see that in quadrilateral ABEC, in quadrilateral ABEC, the diagonals AE and BC bisect each other at the point E. Bisect each other at the point D. Since why? Since BD is equal to CD, which is given, and AD is equal to DE, which is according to the construction. According to construction. So therefore, since in this quadrilateral the diagonals bisect each other, so I can say that it is a parallelogram. But simply we can also prove that, if we take these two triangles, suppose we take in triangle ABD and triangle EDC, ABD and EDC, then we can say that AD is equal to DE and BD is equal to CD. And the vertically opposite angles are equal. It means that angle ADB, that is equal to angle ADC, which is the, so, and I can say angle ADB equal to angle ADC. These vertically opposite angles are equal. Therefore, I can say that triangle ABD is congruent to triangle triangle ADC by SAS rule. By SAS rule of congruency. SAS rule of congruency. So hence I can say that these two are equal. So these two angles are also equal. So I can say angle BAD, that is equal to angle CEB by CP. So I can say that AB is parallel to CE. AB is parallel to CE since alternate interior angles are equal. Similarly, we can show that. AC is parallel to BE. So hence we can say that ABEC is a parallelogram. AC is a parallelogram. Therefore, I can say that these two angles are equal. So I can say that, so angle E, you can draw the figure here again. Plus A, B, C, D, E. So these two angles are equal, and these two angles will be also equal. So I can say that these two are equal. It has been told angle BAD, that is equal to angle CAD, which is given, and so angle BAD, that is equal to angle CED also, which is equal to angle CAD also, which is equal to angle DED also. So hence all are same. Let's say we take it as X, say. So therefore I can say, triangle ABE and triangle ACE are isosceles, since why the two base angles are same. So hence we can say that AB is equal to BE, that is equal to EC, that is equal to CA. Or hence I can say ABC is a rhombus. ABC is a rhombus. So hence you can say that AB equal to AC also, AB equal to AC, or hence I can say that triangle ABC is isosceles. So hence proof. Here actually we should not use only triangle ABD and ACD, since why here the included angle is same, that we can't say, since here it is not told that ADB is equal to ADC, but it is told that BAD is equal to CAD, and it is, and we can use AD is the common side and BD is equal to CD. That have been told, but it is neither told that it is a right angle, uh, nor it, nor they are equal. Is that is not being told. So hence we have to prove in this way. Since here, if we have had to use the SAS rule of congruency, then we have to use the included angle. But here included angle has not been told that they are equal. So we can't use that. So then in question number 34, it is told to prove that the perpendiculars drawn from the vertices of equal angles of an isosceles triangle to the opposite sides are equal. So suppose if we have triangle ABC and DE and CF are perpendiculars from C and E, these two are equal, suppose. So hence AB and AC are equal. Then you have to show that these perpendiculars are equal. So it is given that BE perpendicular to AC and CF is perpendicular to AB in triangle ABC. Triangle ABC thus such that AB equal to AC, and so I can also say so angle B equal to angle C. Or simply I can say such that angle B equal to angle C, it has been told. Then we have to prove that that we have to prove that BE is equal to CF. So how to prove? We have to write the proof, that is, so I will say in triangle ABE and triangle ACF, we say that angle BAE is equal to angle CAF. Since why angle A is common, angle A is common, and angle A is common, and then this, so we can say that A is AB equal to AC also. Since we can say that since angle B equal to angle C is given, and we also know that, and the sides opposite to equal angles are also equal. Sides opposite to equal angles are also equal. So this is equal, and we can also say that angle BEA, that is equal to angle CFA. Since why both are 90 degrees, since it is given that BE is perpendicular to AC and CF is perpendicular to AB. So therefore we can say that triangle ABE is congruent to triangle ACF, by angle and the side. So it is by AAS rule of congruency. AAS rule of congruency. And therefore we can say that BE is equal to CF. Therefore we can say BE is equal to CF by CP/CT. So hence proof. So hope all of you understood the solutions of these questions till the question number 34. Still any doubts if you have, please write that in the comments. We shall obviously clarify them. And please install our Sapience education application also, which shall be obviously helpful for your exam. So thank you everyone. Bye.